Hello, math students. Welcome back to our module on linear equations. This is lesson 28 called Another Computational Method of Solving a Linear System. Our goal for today we will learn a new method for solving systems. The question that I want you to be thinking about in this lesson is, what could you do to one of the equations in a system to make a zero pair of a term? Okay, and remembering zero pair of a term means that you're getting rid of that term from both sides of the equation. Things to know. The best way to describe this is we have two different ways that we can figure out what a solution would be to finding the value of either the y or the x values. And the two ways that I'm going to talk about today are called substitution and elimination. And so I would like you to take a look at these two problems, and the two problems have explicit directions that they want me to teach you so that you know how to do them when you're working on solving systems. So again, these are systems. I don't have the bracket on there. I apologize. I need to get a tool in my equation editor that gets the brackets written in there. But because I don't, I'll draw them in. All right, so this one says use substitution. And if you can recall what substitution means you know what one of the variables equals, and because you know what one of the variables equals, you can substitute that value that the variable equals in for the variable. So let's take a look at this. In this system, we know what y equals for both of them. Y equals 3x minus 5, and y also equals negative 3x plus 7. And since they both are equal to y, what could we say about them? This one equals y, and this one equals y. They're in the same system. Y could only be y, and so we now know that y at one point in time equals 3x minus 5, and we know that y at another period of time equals negative 3 plus 7. So when the directions explicitly say use substitution, then since they're already set up for y equals, then we know that what is really going on here is that they equal each other. Because this one equals y, and this one equals y, and there's only one y in our system, so they must equal each other. So the way that you use substitution is you set them up to equal each other. So we can write 3x minus 5 equals negative 3x plus 7. And the reason why we can do that is because they both equal y. Since they both equal y, then they mean they equal each other. Well, that right there is really, really handy, because what we're able to do now is we are able to solve for x, because x is the only variable that we have. So we need to get all of the x's onto one side. Since this one's negative, and I really don't love negative, I'm going to take this term over there. In order to do that, I have to unhook it from the 7. So remember, I have to do the opposite operation. So this is 3 negative x's. I'm going to add 3 positive x's, giving me a zero pair. What you do to one side, you have to do to the other. And so now I have 6x minus 5 equals 7. And so BU chart, or by now you can just recognize it, I have to get the x by itself. So I'm going to add 5 to both sides. And when I do that, this becomes a zero pair. So I'm left with 6x equals 12. I'm going to divide both sides by 6, and now I know that x equals 2. All right, so now I know that x equals 2. Well, that's great because I know what x equals, but do I really know what y equals? So now I'm going to go back in and I'm going to figure out what y equals. And I'm going to test it with both equations to make sure that it's accurate. So on the first one, I'm going to write y equals 3 times 2, because that's what x equals, minus 5. So y equals 6 minus 5, so y equals 1. Okay? So now we know what y equals and we know what x equals, and we're going to check that one again in just a minute, but let's also check it here. So now we have y equals negative 3 times 2 plus 7. Y equals negative 6 plus 7. So y equals 1. So again, it came out correctly. And now, for the final way to substitute it in, we're going to try it both ways. So in this equation, we have 1 equals 3 times 2 minus 5. So 1 equals 3 times 2 is 6 minus 5, and 1 equals 1. So there you go, boys and girls. You see that it works. So now let's try the second one. 1 equals negative 3 times 2 plus 7. 1 equals negative 6 plus 7. 1 equals 1. So it checked out on both times, or both occasions. And so now we know the point of intersection where they actually will collide, because remember, if they equal a specific point, then we know the answer to this one is 2, 1. Okay? And that's how you were able to find the ordered pair that provides the answer for this system of equations. And when you find an ordered pair that provides an answer to a system of equations, then you know that these lines right here will intersect at 2, 1. Okay? Ta-da! That was pretty cool. That method right there is called substitution. Okay? The other one that I need to introduce to you today, it talks about elimination. And elimination is kind of cool because we like to figure out what we can do to do this one. It's a little more complicated because what you're trying to do is you're trying to get one of your terms to be exact opposites of each other. Okay? So what we're going to do on this one is I would like to change this equation into standard form. So to do that, I'm trying to get this guy back over. So this is going to be 4x plus y equals 6. That's standard form. Now I see this guy, and it's already in standard form, so I'm going to write 2x minus y equals 11. Okay, now they're both in standard form, which is beautiful. What we're looking for with the use of elimination is we're looking for a term that are exact opposites of each other. That means that their coefficients are opposites of each other. That means that their variables are opposites of each other, or their constants are opposites of each other. And we just happen to hit the jackpot on this one because these two are not opposites of each other. We know that. However, this says positive y, and this says negative y. If we were to put a coefficient in there, that would be positive 1y, and this one would be negative 1y. Well, the opposite of positive 1 is negative 1. So as you can see right there, we are golden. Since we have a whole entire term that is opposite of each other, they become a zero pair. So now they're gone. And all you have to do is combine them. So 4x plus 2x equals 6x, and 6 plus 11 equals 17, right? And so now we can solve for x. So we're going to divide by 6 on both sides. So x equals, and 6 goes into 17 2 times, which is 12, and that would be 5, 6. So now we know that x equals 2 5, 6. Okay, so now that we know that, we can use the elimination method because we know what x equals. So I'm going to do it this way, and I'm going to say 2 times 17, 6. I'll go ahead and turn it back into that because that's what I have to do to multiply. Minus something equals 11. So I know that 2 times 17 is 34. So 34 is 6 minus something equals 11. And so to unhook it from this y, I have to subtract it. So I'm going to subtract 34, 6 from both sides, right? And now I have a negative y equals, and if you take this and turn it into 6, that would be 66 sixths, right? So 66 sixths minus 34 sixths gives us 2 and 3 sixths, and that's a negative y, so we have to take the whole thing and multiply it by a negative 1. So I get y equals negative 32 sixths, so it would be negative. It goes in there 5 times with 2 sixths left, which is 1/3. And so now we have the y. So now our job, because we found the y, is we have to check it with both equations and see if it works. So x is 2 5 6, and y equals negative 5 and 1/3. So in this first equation, we have negative 5 and 1/3, and I want to write it this way, negative 32/6, okay, equals, and then this one was 17/6, so negative 4 times 17/6 plus 6. All of that should equal each other. So let's go ahead and see. So we get negative 32/6 equals, we have to have multiplying straight across, so that's 28/68, so negative 68/6. And then if we turn this into 6, then we would get 12, nope, sorry, we'd get 36/6, right? And so 68 minus 36 is 2, and 3, 32/6 equals negative 32/6. Check, it worked. Okay, so that's pretty cool that it worked. Now we have to do this guy really quick. So you have 2 times 17/6 minus 34/6. That's a negative 34/6, right? Because it was a negative 34/6 equals 11, which is the same as 66/6. So let's see if this works. So that would be 34/6 minus a negative 34/6 equals 66/6. Let's see if it does. So, did I do? Oh, no, this is supposed to be 32. I apologize. That's why it doesn't work. 32. Okay. So that's actually a 32. Now we add those because subtraction is the same as adding the opposite. So 4 plus 2 equals 6, and 3 plus 3 equals 6. Denominators are the same, so we get 66/6 equals 66. Check. So it worked out in both instances. And so our ordered pair, here's your x value, here's your y value. Your ordered pair would be 2 and 5/6, comma, negative 5 and 1/3. That is the point of intersection. Okay? So I know that a lot of you hate when it gets into fractions, but you're in 8th grade. You have to be able to do rational numbers with all of this as well. So this is an example of surviving rational numbers. So elimination, what did we do? We found the term that can be eliminated so that we can focus on one variable at a time. You find that variable, then you plug it back in, and you find your other variable. You check it to see if it balances and it's equal, and that's what identifies your point of intersection. Okay? So using substitution this way, using elimination this way. Okay? Both of them, depending on what your numbers are, both of them can be equally easy and fun. You just have to get really confident and really comfortable with using either one, using substitution method or using the elimination method. When you're using substitution and elimination, you're going to see very quickly that you are looking for that point of intersection. All right, so which method is your favorite way to obtain solutions? For me, my favorite method for obtaining a solution is to use substitution. I love using substitution because all I have to do is identify what the value is for one of the variables, and then once I have that identified, I plug it in, and then I'm able to solve. So when you use substitution, just a little hint, it's easiest to use substitution by turning both equations into slope-intercept form, equations into slope-intercept form. And then once you've turned both equations into slope-intercept form, then you know what the y equals. The y equals up here. Then you just do this one equals this one because they both equal y, and then you solve to find what the variable or the value means. Okay? So going back to our goal for the lesson, today we will learn a new method for solving systems. Our new method is the use of substitution or the use of elimination, so we did that. And then what could you do to one of the equations in the system to make a zero pair of the term? You just have to make sure that when you're looking at the term that you have the opposite value of each other. This is a negative 3, this is a positive 3. That is the opposite value of the exact same amount. And so -3 is opposite of +3. +1 is the opposite of -1. So by making your coefficients opposites of each other, then you can eliminate the term and you can solve. Okay? All right, kiddos, that's all I have for you today. Talk to you soon. Bye!